Hello everyone, welcome to another video. Today we'll be talking about inverse trig derivatives. When you see this, it's going to feel really out there, like very weird. It's just because you'll use it later for stuff, but for now it's actually not too bad to do. It's basically just going to revolve around using formulas. So there's a formula for every inverse trig function, but they really come in pairs. One of them just turns out to be a negative of the other one. So I'm just going to show you that and we'll go from there. So if you wanted to use to know the inverse sign, so inverse sign of u, well, this would just be equal to u prime over the square root of 1 minus u squared. And so you just have to plug in u, whatever function it is, to this, and you'll get the answer. And for cosine, cosine is going to be the same exact thing, so u prime over the root of 1 minus u squared. The only difference is we have a negative here. So the cosine has the negative in front, but other than that, it's the exact same. So I'll do an example and you'll see what I mean. So let's just say we had something like maybe f of x so equals to the let's arc sine. So arc sine is the same thing as the inverse, same exact thing, and let's just say it was x squared. So if we wanted to find the derivative of this, we just have to recall the formula. So sines is this one, and we just have to plug in x, or the function for u, with every time we see u here. So u prime is the top, so x squared, the derivative of x squared would be 2x if we bring down the power and decrease it by 1. So just 2x on top. On the bottom we have this root, and inside the root we have 1 minus u squared, so 1 minus, and then it's x squared, so we're just putting in u as it exists in the function, and we're going to square it. And remember, when we're squaring exponents, that's like multiplying them. It's only when they're multiplied by one another, like x squared multiplied by x squared, that's when we would add them. But when there's an exponent on the outside, that's when we do multiply them. So we would write this as f prime of x equals to 2x over the root of 1 minus x to the 4th power. And this would be your answer to that question, so this one right here. Now if it asked for cosine, it would be the same exact thing. You would just put a negative out front. So negative or positive is the only thing that really separates this. So knowing that, let's go ahead and try the other two kind of sets, because they sort of come in sets, just like this. So if we wanted to find tangent, so arc tangent of u, well, arc tangent of u is kind of an easier one to remember. It's just going to be u prime all over 1 plus u squared. So there's no square root. It's just going to be u prime over 1 plus u squared. So that just means that cotangent would follow something similar to cosine here, so it's going to be u prime over 1 plus u squared, and cotangents will just be negative. So if we wanted to do one, let's say we had a pretty interesting one to do. Let's say we had the arc tangent of, let's just say, the square root of x. So something rather simple, but it's going to involve us to use our tricks here. So if we wanted to do this, let's just use our tangent expression. So it's going to be u prime. If you don't know, the square root of x, its derivative is going to be 1 over 2 root x. If you don't know that, you can do it out. So that's the root of x is the same thing as x to the 1/2. We bring down the power, that turns into 1/2 x. We subtract by 2 over 2, which is just 1, turns into negative 1 over 2. And if we just write this out again, we put the x root on the bottom, so that's root of x, and then that's a half, and the half we can write as like this. We just found the same exact thing. So if you don't memorize the root of x, you can find it too. I find it is helpful to memorize it though. So, but now that we know it's 1 over 2 root x, let's now put that into the expression. So the f prime of x, so we're just kind of going down here for it. So f prime of x would be the u prime, so 1 over 2 root x. Remember, this is just the derivative of the root of x. And it's going to be over 1 plus u squared. So 1 plus the square root of x squared. So if you know, the root of x and the root will cancel each other out. So really this is the same thing as 1 over 2 root x over 1 plus x. Now this is technically the answer. The only issue is that this is a complex fraction. Teachers typically don't like complex fractions as an answer, although it is technically the same thing. So we just want to get rid of it by taking the common denominator and multiplying it to both. So this would be 2 root x in this case. So this would cancel, and we'd multiply by 2 root x here as well. And so if it cancels, you just have a 1 up here. So we just keep the 1. So the 1, so this one right here. So the 1 over the 1 plus x multiplied by the 2 root x. And that would be the same exact thing. So just a bit of simplifying, but that's how you would do arctangent. Now the last set of examples would be arcsecant and arccosecant. So arcsecant is actually just going to be very kind of similar to sine. There's more things to it. So it's going to be u prime, so derivative on the top again. Then we're going to have a little bit different. We're going to have the absolute value of u, and then we're going to multiply by this time the square root, but the u squared is going to be first, and then it's going to be the minus 1 after, instead of the 1 minus being first. But everything else, the process is the same. So let's just say, for our example here, we had the arcsecant of, let's just say it was of maybe 3x. Okay, so to find the arcsecant of 3x, we're just going to, oh, and I want to make sure this is f of x. So f prime of x is going to be the u prime. So 3x's derivative is just going to be 3, because the derivative of x is 1. So it's just 3. And then we're going to have the absolute value of u. So the absolute value of u is going to be 3x. So just putting u in, absolute value, and then the root, and then we're going to have the 3x squaring it. So we're just squaring the 3x because it's the u, and we're going to subtract by 1. Okay, so now we just have to do a bit of simplifying. So this is going to be 3 over the absolute value of 3x, so this is all the same. The difference is here. So when we square an x, just be careful. It's not just going to square the x. A very common mistake is to forget that it's going to square the 3 as well. So it's going to be 9x squared. So 9x squared because we're squaring the 3 and the x. And then it's going to be minus 1. Now, this is technically the answer, but keep in mind what we can do, we can go a little bit further. Because we can take out a 3 from the absolute value, it's the same thing. So if we take a 3 out of absolute value, then it's just 3 times the absolute value of x by the root of 9x squared minus 1. And then we can just go ahead and cross out or cancel these 3's, since they form a 1. And then we'll have the final answer, which in this case is going to be 1 over the root of x, or the absolute value of x, I should say, times the root of 9x squared minus 1. So that would be kind of what you need to do in this case. And just remember, if we had a cotangent or something for this, the equation is the same, we just have a negative. So if it was cotangent, we'd have a negative here, and if it was a cosecant, and I didn't write it because it was the same thing, it's a negative, but it would just be the u squared over the absolute value of u, root of u squared minus 1, we just have a negative in front instead of a positive. But just know that they're usually just going to give you sines, tangents, and secants for the most part. Sometimes they may give you a other one with the negative, but since they're the same expression, they usually just test you on the ones that are more common, so these 3. But this was kind of just inverse trig derivatives. So thanks for watching. I really appreciate it.